Hello. In this C programming video, we're going to be implementing an example with threads that involves parallel array sorting. The program we're going to use here, make here, stores an array of n integers using 4 distinct threads to demonstrate parallel processing and synchronization, or precedence. So the flow of execution, which is enforced by pthread join and main. First, the main thread is going to read n and initialize the original array. Thread 1, which is our copy thread, is going to allocate an auxiliary array and copy the data. Thread 2, which is our sort left array, and thread 3, which is our sort right array, will sort the two halves of the auxiliary array in parallel. And then finally, thread 4, which is our merge thread, merges the two sorted halves back into the original array. If you find this video informative, please give it a like and feel free to comment with more video suggestions. So to get started here, we're going to obviously include the libraries that we need. So first one we're going to do here is include our standard input-output library. Next, we need to include our standard library. Then we need to include our pthread library. Then we need to include our time library. And then finally, we need to include our Unix standard library. So now that we have our 5 needed libraries implemented, the first thing we're going to do is to define our shared data structure. First thing we need to do here is to define our structure. So we're going to do type def struct, and then inside our struct here, first thing we need to do is to declare our final destination array. So we're going to do int and then pointer to the original, we're going to call it original array. Then we're going to define our auxiliary array or the working array. So we're going to do that, we're going to call it aux array. Next thing we're going to do is to define our total size of the array. So we're just going to do int n. Next, we're going to define our start index. So we're just going to call it start index. And then finally, we're going to declare our end index. We're going to call it just end index. And then we're going to call our struct array data. So again, as a review, our first value is the destination. Destination array. Our second definition is our working array. Our third thing is our size of the array. Our fourth is to define where we start sorting. And then finally, our fifth one is where we end sorting. And then obviously, this is our name of structure. Next, we need to declare a global structure to pass to the worker threads. So we're just going to define this with array data, the array data variable type, and we're going to call it G data. So again, this is our global structure. And then next, we need to we're going to define a small comparison function for sorting. So we're going to call this int return type, and we're going to call it compare ints. And then inside the function, we're going to pass in 2 constant void pointers. So constant void a, and then constant void b. And then this is simply going to return the pointer of casting A into an in pointer, and then we're going to subtract the same thing but B. So again, as a review, this is a comparison function for sorting. And then we will use that in good bit of examples here. So the next thing we need to define is our thread functions. Our first thread function is going to allocate the auxiliary array and copy the data. So we're going to define this as we do any thread definition with void, and we're going to call this thread copy, and then inside there we're going to pass in our void arg pointer. So the first thing we're going to do here is we need to cast. So array data, then a data pointer, and then we're going to make that equal to casting the arg to array data, an array data pointer. Next thing we need to do is inform the user that we're starting a copy of a specific of whatever the number of elements are. So again, as I've done in previous videos, we're going to be specific on in our print statements, we're going to say what thread's doing what. So thread 1, which is our copy thread, starting copy of decimal elements, and then we're going to pass in our data with our arrow notation. We want to do the size of the array, so data n. Next thing we're going to do here is allocate memory for the auxiliary array. So we're going to do data aux array, and we're going to make that equal to casting to an int pointer, and then malloc, and then inside the function we're going to pass in data n, and then times size of int. So next thing we need to do here is we need to see if the data of the auxiliary array is null. If that's the case, we failed. So we need to let the user know. So we're going to do if data auxiliary array. If that is equal to null, we need to inform the user. So we're going to do p error, and then we're going to pass in thread 1 again, just so we're labeling things, and then we're going to say failed to allocate memory. And then we're going to do pthread exit, and then we're going to pass in our void pointer, and then 1, because an unsuccessful execution there. But assuming that everything worked correctly, we can move on now. So next thing we're going to do is we're going to copy the elements from an original array to the auxiliary array. So quite simply, we're going to do for int I equals 0 I is less than data n, and then we're going to increment I. So simply put, we're going to do data aux array, and then wherever we are at the index, we're going to make that equal to the data original array, and then wherever the index is there. So once that's done, next thing we're going to do is we're going to do a small delay. So we're going to do usleep, and then let's just say for a very small delay, so we're going to do 50,000 there. And then finally we're going to do printf. And then we're going to say that the data copy is complete. And then the auxiliary array is ready. I keep doing 2 L's. And then we can do we can return null. So our second and third threads are about sorting a specific range of the array. So we're going to do that with our standard definition. We're going to do void, and then we're going to call this one thread sort, and then inside we're going to do a similar thing. We're going to pass in void arg. First thing we need to do is cast. So array data, and then we're going to call it data again. We're going to make that equal to casting arg to array data pointer. Next, we need to declare the total number of elements in this half. So we're going to declare a new variable called size, and then we're going to make that equal to data end index minus data start index. Then we need to get the pthread ID for logging. So we're going to declare a long variable, and we're going to call this one thread num, and we're going to make that equal to pthread self cast to long. So we're going to do long Next thing we need to do is we're going to print that we're sorting for a specific range. So we're going to do, this is going to be a long one, so I'm going to make this multiple lines. Printf, I'm going to put our line first, so we're going to say thread, and then this depends what the number is. So it's not, this is thread 2 and 3. So I'm going to do thread LU, and then I'm just going to label this time, so sort, and then we're going to be sorting range from our first decimal, which I'll get to in a second, to our second decimal. And then we're going to say the size as well. So size, and then another decimal. And then we're going to pass in here our thread number first as our first argument there for long. Our second is going to be data start index, so our second decimal there. Our third argument is going to be our end index. And then finally, our fourth argument is just the size for our fourth format specifier there. So now we're going to use qsort here. So we're going to do qsort, and then we're going to pass in data auxiliary array plus data start index, and then we need to pass in the size, then the size of int, and then compare ints. And then we can notify the user that the sorting is actually complete. So we're going to do thread, again, same thing here. So sort, and then sorting is complete. And then finally we can return null. So let's do a quick review of our copy and sort threads here. So with copy, again, the first thing we need to do in both of these is cast. And with our thread copy, we're going to notify user we're starting. In our next line, we are allocating memory. And then we are handling possible error. So we're going to notify the user and exit thread. Well, with an error. And then we are simply copying from original to the working array. And then we're going to we're going to sleep for demonstration. And then finally, we're going to notify the user that we're done with the copy, and then exit the function. And then down here with thread sort, again, we're starting with cast. But here, it's a little different. First thing we need to do is determine total elements in whatever half we're in. Then we are getting an ID, getting a thread ID. And then we're notifying the user that we're starting. And to make this a little more self-explanatory, I will define these arguments here. So the first one is our thread number, then is our start index, then is our end index, and then finally the last argument is our size determined above. And then with qsort, it's important to note that the base address for the sort is the start of the auxiliary array, plus the offset defined by data start index. So again, I'm going to make this a little more easier to see here, and then let's explain each argument. So again, the first one is our pointer to the start of the segment. Then is obviously the number of elements in segment. Next is the size of each element. And then finally is the comparison function. And then once that's done, we're going to notify the user that we're done. And then we are exiting the function. So now let's move on to our thread merge thread here. So thread 4. So we're going to call this one thread merge. Again, we're defining this in a very similar way as before and passing in a void pointer for arguments. So again, just like the last two, the first thing we're going to do is cast. And then we're going to notify the user that we're starting. So we're going to do thread. So this is thread 4. So thread 4. For the sake, I'm going to put a new line character there. Thread 4, starting merge operation. Then we're going to actually get started here. So first, we need to we're going to define a local variable called n, which is just a copy of our data.n. Well, not data.n, but with the arrow pointer. The arrow notation, and then we need to define our midpoint. So we're going to call it int mid, and that's just going to be n over 2. Now we need to define 3 pointers here for the merge operation. So first is our left half pointer, which we're going to call I. Then is our midpoint, we're going to call it J. And then finally is int K, which is simply also 0. I'm sorry. So I is the pointer for the left half. J is the pointer for the right half, and then K is just the destination, the original array. That's initialized to 0. Now we're going to get into our merge loop. So we're use a while loop here. So while I is less than mid, and J is less than n. While both of those conditions are true, we're going to do an if-else. So if, we're checking to see if the data aux array at index I, if that is less than or equal to data aux array at index j, if that condition is true, we're simply going to do data original array and then passing in k incremented. We're going to make that equal to data with arrow notation aux array at incremented of I. And then we're going to do else. So otherwise, if that's not true, we're going to do data original array at k incremented is going to be equal to data aux array at j incremented. So note the difference there. And then once we exit the while loop, the next thing we're going to do is copy the remaining elements from the left half if there's any. So we're going to do while I is less than mid, we're going to do data arrow notation original array and then k. We're going to make that equal to data aux array at I incremented. And then next we're going to copy the remaining elements from the right half if there's any. So we're going to do while j is less than n. We're going to do a similar thing. We're going to do data arrow notation original array at k incremented is equal to data aux array at I incremented. And then we're going to do some cleanup here. So we're going to free the data of the working array, and then we're going to prevent a double free. So we're going to do data at aux array that's equal to null. Almost a double equals there. And then we're going to notify that the user that the merging is complete. So printf thread 4 merge complete, and then auxiliary memory freed. And then we're going to return null. So again, as a review of this thread merge function, first we're casting, then we're notifying the user that we're starting. And then here we are defining some pointers. So defining size of array, and we're defining our midpoint. And then we're defining another pointer for left half. Then j is our pointer for right half. And then our k is our pointer to the original array or destination. Then we are getting into our merge loop, which I already explained. Then we're copying elements from left half if left. Well, specifically to make sure grammar-wise, if any are left. And then we're going to be copying the elements from the right half. And then finally, we're going to be freeing our memory. In addition, we're going to be preventing double free. We're going to notify the user that we're done. And then we're going to exit the thread. Or function, probably a better word to use. So now that we have threads 1, 2, 3, and 4 done, so specifically our copy data array or function or sorting arrays, otherwise known as like threads 2 and 3, and then emerging thread or thread 4, we can finally get into our main function, which is our controller. But I kind of lied here. First, let's do a quick auxiliary or better word, the utility function that main will use. So this is going to be just be the printing the array. So we're going to do void. We'll call this print array, and then inside here we're going to pass in constant char pointer called label, and then our int the array, and then the size. So inside here, we're going to just do some decorative stuff. So we're going to pass in S, which is our label. And then for int i equals 0, I is less than size, and then incrementing I, we're going to print. So inside here, we're going to do decimal, and then S. So obviously, we're going to be passing in array at I, and then we're going to be passing in I if I is equal to size minus 1, using our ternary there. And then we're going to do printf, and we're going to end off our array there. We don't really need period. So now we can actually get into our main function here. So we're going to do int main, and then we're going to pass in our args, not int, char, and then char. So first of all, if the arguments is if the size is not equal to 2, we're going to print out an error. Wrong character. We're going to be passing in And we're going to return 1. So first thing we need to do here is set up the array, the data and the array size. So we're going to do g data dot n. That is going to be equal to whatever we passed in, right? So if it's less than or equal to 0, we need to print out an error. So if gdata.n, if that is equal, well, if that is less than or equal to 0, we need to print out an error. So f print f std error. It needs to be positive integer. And then we're going to return 1. And then also we need to check to see if it's less than 2, because obviously there's no need to use this program. We're going to print out a similar error here. And then we're going to return 1. But now that we have that out of the way, we can allocate the original array memory. So we're going to do g data dot original array. That is going to be equal to casting the copy of g data dot n times the size of int. Next, we're going to see if the original array is null. So if that is equal to null, we need to say that we failed to allocate the memory. And then we're going to return 1. And then we need to, so assuming that is successful, we need to do g data dot auxiliary arrays is it going to be equal to null. That is going to, this is going to be allocated by thread 1. So now we can use a seed and populate the original array with random values. So we're going to do srand, and then we're going to be passing in time, and then passing in null. And then we're going to populate the array. So we're going to do for int I equals 0, I is less than g data.n, otherwise known as the size. Then we increment I. And then in here, we're going to populate the original array with random values. So we're going to do g data dot original array at index I. That is going to be equal to rand percentage sign 100. So, and otherwise known as values from 0 to 99. Then we're going to print. We're going to print a statement here. Printing out the array. We're going to say, okay, we're starting the parallel array sort demonstration. And then we're going to pass in the size of the array just so the user knows. And then we're going to call print array to print out the original unsorted array. So again, our print array function there. And then we're going to calculate the array partition boundary. So otherwise known as mid. So int mid, that is going to be equal to g data.n over 2. Next, we need to set up the thread-specific data structure, so threads 2 and 3. So we're going to do array data, and then we're going to call this data for thread 2. That's going to be equal to g data. gdata. And then we need to define our start index. So we're going to do data t2 dot start index. That is going to be equal to 0. And then data t2 dot end index, that is going to be equal to mid. Next, we're going to set up our thread specific data for thread 3. So we're going to do array data. We're going to call this data t3. We're going to make that equal to gdata again. And then we're going to set up our start and end index as well. So we're going to do data t3 dot start, not auxiliary array, but start index. That's going to be equal to mid. And then our end index, that's going to be equal. To gdata.n. Next, we're going to define our thread handler. So we're going to do pthread. So pthread t, we're going to do t1, t2, t3, and t4. And then we're going to define an int called result. So our first stage here is copy. So inside stage 1, first thing we're going to do is say that we're in stage 1 itself. Then we're going to define a result. And we're going to make it equal to pthread dot underscore create. And then we're going to pass in the address of t1. Our second argument is going to be default. So we're going to do null. Our third argument is the function name, so thread copy. And then the fourth argument is the address to gdata. So if the result is not equal to 0, there's an error. So we're going to print out the statement. And then we're going to return 1. But otherwise, that it was successful. So we're going to join the thread. So we're going to pass in t1 and then null. And then we're going to check to see if t1 failed, otherwise known as a memory allocation error. So if gdata dot auxiliary array, if that is equal to null, we're going to pass in that there was a fatal error. And then we're going to free the data. So gdata dot original array. And then we're going to return 1. But assuming T1 is successful, we can update T2 and T3 structures with the newly allocated auxiliary array pointer. So we're going to do data T2 dot aux array. We're going to make that equal to G data dot aux array. And then the same thing with T3. So now we can get into stage 2, which is the parallel sort. So the first thing we need to do here is we're going to inform the user that we're in stage 2. Then we're going to sort the first task. So we're going to make result equal to pthread dot create, underscore create, and then we're going to pass in the address of T2. We're going to pass in null. We're going to pass in thread sort, that function, and then the data, the address of the data of T2. And then if the result is not equal to 0, we're going to print out a similar error here. and return. But otherwise, we can continue. So line 159 separates the first half, and now thread 3 can separate the second half. So we can do very similar thing here, but instead of T2, T3. And then if the result is 0, is not equal to 0, we can print out an error and return 1 as well. Now we're getting to the synchronization point. We're waiting for T2 and T3 to finish both sorts. So we're going to notify the user that that's the case, and then we're going to join both 2 and 3 in a similar method as before. At this point, both halves are sorted, and then we're going to be ready to merge. So now we can arrive to stage 3, which is merge. So we're going to first of all inform the user that we're in stage 3. And then we're going to merge and free the auxiliary array. So we're going to do result. We're going to make that equal to pthread create for thread 4. But instead of thread sort, it's going to be thread merge. And then passing in the memory for, but not data T4, but instead memory address of G data. Then we're going to do a similar error checking thing here. If the result is not equal to 0, we can print out that there's an error. And then we're going to wait for T4 to complete the final merge and cleanup. So we're going to do that with pthread join T4 and then pass in null. Now we're going to conclude with some final cleanup here. So first we're going to inform the user that we're done. So we're going to print the final result, which is the final sorted array, passing in the original array now, and then the size of the array is we need in our utility function that we already did. And at that point, we can free the original array. So we're going to do free gdata.original array. And then finally, we can return 0. So now that we're done with our program here, let us open up new terminal and test this out. So we're going to do gcc parallel sort.c. We're gonna call it parallel sort, and then we're going to do our pthread argument. So once that's compiled, we can run it. So we're going to do, let's just start with an array of 5 elements. So as you can see, it did it. We have our original unsorted array. We copied the data. We did the parallel sort here. Note these were done at the same time. Merge and cleanup, and then we printed our final sorted result. If you found this video informative, please give it a like and comment with any questions. Especially these more long format videos are important, where I go in depth and explain every line of code. Subscribe to the channel to get more videos like this. And otherwise, thank you for your time and have a great day.